Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to discuss about pyrazole. I will describe here structure of pyrazole, synthesis of pyrazoles, and properties of pyrazole. So let us start learning of pyrazole. Look at here structure of pyrazole. Pyrazole you can see in name OLE means it is a 5-member ring. So there are two nitrogens in pyrazole. One nitrogen similar to pyridine and another nitrogen which contains hydrogen similar to pyrrole. So pyridine like nitrogens and pyrrole like nitrogen. You can see in this structure. You remember pyridine structure and pyrrole structure. Now you can see the unhybridized p orbital in pyrazoles and sp2 hybridized orbital. Now properties of pyrazole. First, we have learned about aromaticity. Pyrazole is aromatic or not? It will clear from this point. Pyrazole have 3 carbon and 2 nitrogen. All are sp2 hybridized. You know my friend, sp2 hybridization is planar. It makes a planar pyrazole ring structure. Each ring atoms also contains unhybridized p orbital that is perpendicular to the plane of sigma bond, plane of ring. In case of pyrazole, p orbital are parallel to each other. So overlapping between p orbital is possible. The total number of non-bonding electrons are 6, 3 of 3 carbon, 1 from 1 nitrogen and 2 of the other nitrogen. The resonance of 6 electron follows the Haeckel's rules. So pyrazole is aromatic. Now properties of pyrazole. First property is tautomerism. Pyrazole showing tautomerism. Rapid migration of hydrogen from one nitrogen to other. You can see 3,5 methyl pyrazole, either 3. So it is in equilibrium. The second property is hydrogen bonding. You know pyrazoles contains NH. So this NH associated with the hydrogen bond with intramolecular nitrogen of other pyrazoles. So there are 2 types of hydrogen bonding possible in pyrazoles. You can see 2 hydrogen bonding within 2 molecules, cyclic dimer. And this is very important. Cyclic dimer means they are making 6 member with the help of hydrogen bond. Now synthesis of pyrazole. First synthesis from pyrimidine. You can see the structure of pyrimidine, 6 member with 2 nitrogens. It undergo aqueous hydrazenes. On heating, this 6-member ring converted into 5-member ring with 2 nitrogens, but both 2 nitrogen are not same in pyrazole. So pyrimidine is very susceptible to nucleophilic additions. It reacts with hot hydrazine solution to give pyrazole. Now, mechanism follow addition of nucleophile, ring opening, ring closure, ANRORC sequence. Addition of nucleophilic, ring opening, ring closures. RO means ring opening, RC means ring closing, AN means addition of nucleophile. So you can see the scheme: nucleophilic additions, then ring opening, then ring closures, and then your pyrazole. Now norpyrazole synthesis. Reaction convert a hydrazine or its derivatives and a 1,3-dicarbonyl compound to a pyrazole using an acid catalyzed. You can see in reaction scheme 1,3-dicarbonyl compound. This is active methylene compound. Undergo reaction with hydrazine, acid catalyst, then disubstituted pyrazole will form. Now the mechanism. You can see acid how attack on oxygens, and then hydrazine attach on carbon, making carbon nitrogen single bond. Then rearrangement, then breaking of OH bond, formation of imine, and then formation of cyclic compound. Cyclization occurs through the lone pair of nitrogens on carbonyl carbon, and then further rearrangement. After dehydrations and hydration, you will get the pyrazole. Now unsymmetrical dicarbonyl compound react with methyl hydrazine. It gives 1,5-dimethyl 3-phenyl pyrazole and 1,3-dimethyl 5-phenyl pyrazole. These two compounds are in isomeric mixture. From nitrilamine, pyrazoles are produced by the dipolar cycloadditions. Dipolar cycloaddition is also very important cycloaddition, which is a part of pericyclic reaction between alkynes with nitrilamine, and then you will get the pyrazole. From diazo compound adds to an acetylenic derivative gives pyrazole. You can see formation of 3,5-dicarbomethoxy-4-phenyl pyrazole from acetylenic derivatives. Now reactions of pyrazole: electrophilic addition to nitrogen, protonation basic properties. Pyrazoles accept proton, act as a base. In this scheme, you can see it react with the acid and forming pyrazolium cation. Electrophilic addition to nitrogen in alkylations. This is also properties of pyrazole. You can see the formation of N-dimethyl pyrazolium salt after removal of reaction with the methyl halides. And then it is in equilibrium. Pyrazole as a base remove protons, and then N1, N2 dimethyl pyrazolium salt. Electrophilic addition to nitrogen. You know, my friend, pyrazole react with alkyl halide and first gives N-alkyl pyrazolium salt. This salt can lose an N proton in an equilibrium with unreacted pyrazole, generating N-alkyl pyrazole. N-alkyl pyrazole react with alkyl halides and gives N1, N2 dialkyl pyrazolium salt. So electrophilic substitution to carbon. This is another. Pyrazole undergo electrophilic substitution reaction at fourth position. Electrophilic attack at possible position with intermediate carbon 3, carbon 5, carbon 4. So intermediate with positive azomethane N highly unfavorable. So fourth positions is much more favorable. Now electrophilic substitution to carbon. Electrophilic attack at carbon 3 and carbon 5 generate highly unstable, positively charged diazomethane intermediate. Electrophilic attack at carbon 4 completes without any such highly unstable intermediate. Thus, transition stage is much higher for carbon 3 and carbon 5 attack than carbon 4. So, electrophilic attack takes place readily at neutral or alkaline media as pyrazole protonated. Pyrazole is more resistant to electrophilic attack than pyrazoles. Now, you can see the electrophilic substitution to carbon, nitrations, halogenations, oxidations, and reduction. In reduction, you can see 1-phenylhydrazole. It gives 1-phenylpyrazolidine because this is the complete reduced ring. Now, ring opening reactions. You know, my friend, N-substituted pyrazole reacted with a strong base, sodamide, cause ring opening. You can see NNH2 ring opening and then acrylonitrile derivatives. Now, medicinal uses of pyrazole. Many synthetic pyrazole compounds are of importance as dyes in medicine. Antipyrine used as antipyretic analgesic, tetrazine as a yellow dye for food, and phenylbutazole anti-inflammatory drugs. You can see the structure of phenylbutazones and structure of antipyrine. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.